Now this is the another problem that involves trigonometry and limits. So we have a function that is f of n and theta, and that is continuous product of 1 minus tan square theta upon 2 to the power r. So we have to find the limit n tends to infinity f of n theta. Okay, so let's solve it. So here we can see that if we divide it by 2 tan into theta to the power theta upon 2 to the power r, we will get tan theta upon 2 to the power n minus 1. Okay, so let's do that. I'm gonna first analyze this. So what I'm gonna, so f of n into theta equals to pi continuous product r equals to 1 to n. Okay, and this is 1 minus tan square theta upon 2 to the power r upon so what I'm going to do is I'm going to multiply 2 into tan theta upon 2 to the power r, and because I've divided it by this, I will multiply it also. So this is 2 tan into theta upon 2 to the power r. Now I just did this manipulation just to get a form of tan 2 theta. So we can write this thing as 1 upon tan 2 to the power tan 2 theta, and if theta is this, then 2 theta would be tan theta upon 2 to the power r minus 1. Okay, this would be our, and here we have 2 into tan theta upon 2 to the power r. Okay, now, and this is actually a continuous product, so we have to multiply it from 1 to n. Okay, so we have to multiply it from 1 to n. Now what is this? Just starting just putting values of r. So this is 2 to the power n, because we are going to multiply it n times. So this is 2 to the power n, and here we can see that it is tan theta by 2 upon tan theta. Here we can see it is tan theta by 4, and here it is tan theta by 4, and here it is tan theta by 2. Here we can see it is tan theta by 8, and here it is tan theta by 4, all the way up to tan theta upon 2 की power n divided by tan theta upon 2 की power n minus 1. Okay, now we can see that this everything is will be cancelled here. So this everything will be cancelled, and we will be left with, here we can see that we will be left with f of n theta would be, f of n theta will be actually equals to this would be 2 to the power n into tan theta upon 2 to the power n upon tan theta. Okay, this tan theta, because this is only that is left in denominator. So we have to find, and therefore limit n tends to infinity f of n into theta equals to limits n tends to infinity 2 to the power n tan theta upon 2 to the power n upon tan theta. Okay, what I'm going to do is, we know that this thing is tending to 0, and we know this particular limit x tends to 0, tan x upon x, that is equals to 1. So we have to create this particular thing in denominator also. So I'm going to multiply it with theta upon 2 to the power n, because I have multiplied it here, I will multiply it here, and so this will be cancelled, and this particular limit will tend to 1. So our answer would be theta upon tan theta. So that's the second problem. It's a nice problem.